In the darkness of a September night, the universe erupted. Two stars ignited as twin earthquakes, magnitudes 6.2 and 5.8, struck Venezuela within 11 minutes. Simultaneously, a solar storm collided with an interstellar comet, C-2023 V1, racing at 170,000 miles with a tail stretching over 5 million miles. This cosmic pileup, compressed into 72 hours, defied explanation, with a probability of less than 0.01%, sparking debates among astronomers. Was it coincidence or a hint of something deeper? If that thought stays with you, hit like, subscribe, and tell me in the comments what you think it all means. And if you want others to hear the same silence, share this video on X, Facebook, Reddit, or wherever you gather with curious minds. Thank you. You're helping us listen a little closer. The clock began ticking just after midnight Universal Time. At 2:12 a.m. UTC on September 23rd, the first nova, V1935 Centauri, blazed in Centaurus, outshining a billion suns. Telescopes in Chile and South Africa captured the outburst, triggering a global alert. Just 14 hours later, a second nova, V2491 Cygni, exploded in Cygnus, disrupting satellite communications. As the twin novae faded, the solar storm intensified. A coronal mass ejection struck Earth's magnetic field at 1:47 p.m. UTC on September 24th, triggering a geomagnetic storm. Auroras danced as far south as the Caribbean, while power grids in Canada and Scandinavia faltered and GPS signals were disrupted. Meanwhile, the interstellar comet plummeted toward the inner solar system, shedding fragments that left craters in Siberia and Australia. The impacts registered as faint seismic tremors worldwide. Chaos peaked on September 25th when a third nova, V3992 Persei, erupted erratically in Cassiopeia, puzzling astronomers with its unstable light curve. As the 72-hour window closed, the universe seemed to pause. The twin earthquakes trio of novae, solar storm, and interstellar comet left scientists reeling, their understanding of celestial mechanics shaken. Yet within this chaos lay a strange harmony, as if the universe were playing a symphony only it could hear. The search for meaning began, driven by the hope that within this chaos there lay a hidden order, a melody waiting to be discovered. Section 1. Stellar Fury. A nova is more than a flash of light. It's a thermonuclear eruption on a white dwarf, a dead star that steals hydrogen from its companion until the fuel ignites in a runaway chain reaction. The explosion rips through the star's outer layers, hurling gas into space at thousands of kilometers per second. V1935. Centauri's blast was no exception, its shockwave heating the ejected material until it glowed brightly in visible light, and even more intensely in gamma rays and X-rays. The energy released in such an event is staggering, equivalent to the total output of our sun over thousands of years, compressed into a detonation lasting mere days or weeks. The shockwaves generated by these explosions act as cosmic particle accelerators, propelling matter to near light speeds and seeding the interstellar medium with enriched material. Gabriela Moya, an amateur astronomer in Valparaiso, Chile, was the first to confirm the outburst. Despite clouds and power cuts, she persisted, scanning the sky with remote telescopes. Her report reached the Central Bureau for Astronomical Telegrams at 2:12 UTC, triggering a wave of confirmations across the Southern Hemisphere. For Moya, the thrill of discovery came with a burden, the responsibility of being first. But she wasn't alone for long. Within hours, the nova's coordinates were flashing through global networks, a beacon of cosmic violence in the night sky. Professional observatories from the Cerro Tololo Inter-American Observatory in Chile to the South African Astronomical Observatory quickly trained their instruments on the event. The nova's brightness peaked at magnitude 5.1, making it visible to the naked eye under dark skies, a rarity for such distant events. Yet the universe wasn't done. Just 2 days later, another white dwarf in Sagittarius erupted. V79994 Sagittarii reached magnitude 6.2, teetering on the edge of unaided visibility. High-energy satellites like Fermi and Swift caught the event almost instantly, recording a rapid spike in gamma and X-ray emissions. The twin eruptions raised questions about the underlying mechanisms of novae, particularly the role of accretion rates and the binary systems that fuel these explosions. Astronomers noted that both events occurred in regions with high stellar density, suggesting that gravitational interactions might play a role in triggering such outbursts. What links these novae is the violence of their shock signatures, visible in both their light curves and high-energy emissions. These weren't gentle brightenings, but thermonuclear explosions unfolding in binary systems light years away, yet bright enough to etch their story across our sky. The light curves of both novae showed rapid rises to peak brightness, followed by gradual declines, a hallmark of classical nova behavior. Spectroscopic observations revealed the presence of ionized hydrogen, helium, and heavier elements, evidence of the nuclear fusion processes powering these explosions. But while astronomers marveled at the spectacle above, the Earth below was far from peaceful. Observation. The timing of these novae, just days apart, sparked speculation about a potential connection. Some researchers proposed that a common external factor, such as a passing gravitational wave or a dense interstellar cloud, might have influenced both binary systems. However, most astronomers attributed the proximity of the events to coincidence, given the vast distances involved. V1935 Centauri lies approximately 10,000 light-years away, while V7994 Sagittarii is situated roughly 12,500 light-years from Earth. Interpretation. The data from these novae provided valuable insights into the physics of white dwarfs and their companion stars. The intensity of the gamma-ray emissions in particular suggested that the shock waves were accelerating particles to energies far higher than previously thought. This challenged existing models of nova explosions and opened new avenues for research into the dynamics of these binary systems. Additionally, the rapid detection and global collaboration in studying these events highlighted the growing importance of amateur astronomers and automated sky surveys in modern astronomy. Speculation. Could these novae herald a new era of stellar activity? As telescopes and satellites grow more sensitive, astronomers anticipate detecting more of these explosions, potentially uncovering patterns or triggers that were previously unknown. Some theories suggest that novae might play a role in seeding the universe with heavy elements, contributing to the formation of planets and even life. Others point to the potential for novae to act as laboratories for studying extreme physics, offering insights into the behavior of matter under conditions unattainable on Earth. Section 2. Shaken Foundations. Just after sunset on September 24th, the ground beneath Venezuela convulsed. A magnitude 6.2 earthquake struck near Monte Grande, its shallow rupture racing to the surface, shaking homes and sending power lines swaying. The local hospital, already short on supplies due to years of economic strain and political instability, scrambled to set up triage outside as aftershocks rolled in. The building, constructed in the 1970s, groaned under the stress, its faded pink walls now etched with fresh cracks that stretched like veins across the worn facade. The smell of dust and old concrete filled the air as chunks of plaster crumbled to the ground. Senior nurse Maricela Rivas, who had just ended her shift, found herself back in the thick of it, guiding patients onto colour-coded tarps spread across the parking lot. Her voice, steady over the hospital's WhatsApp group, relayed injuries and urgent needs as volunteers rigged up makeshift water stations and moved the most critical cases away from compromised structures. The scene was one of controlled chaos, with medical staff and community members working together under the glow of flashlights and the distant hum of emergency generators. Ambulances navigated through streets littered with debris, their sirens cutting through the night as drivers relied on memory and instinct to find safe paths. 5 hours later, the ground moved again. This time a magnitude 6.3, deeper at 14 kilometers, but centered almost directly beneath the same region. The sequence followed a classic stress transfer pattern, one fault segment slipping, then loading the next. Seismologists working through the night mapped the rupture's progression along the Okernon fault zone, their analysis pointing to a typical aftershock decay known as Amori's Law. But for the people of Venezuela, this was no academic exercise. It was a fight for survival. The earthquakes had struck a region already grappling with hyperinflation, food shortages, and a healthcare system buckling under the weight of a prolonged crisis. In the darkness, families huddled together, their fear amplified by the knowledge that help might be slow to arrive. The sound of children crying mingled with the whispered prayers of parents who had already endured years of hardship. The tremors had disrupted communication networks, leaving many areas cut off from the outside world. In the immediate aftermath, improvisation became the rule. With only 3 operating tables and intermittent power, Rivas and her team prioritized children and the most severe trauma cases. They rotated patients outdoors as aftershocks hit, using flashlights to guide IV lines and monitor vitals. Local radio stations relayed updates from the hospital, broadcasting lists of needed supplies and safe routes for ambulances. In those hours, the hospital became a nerve center, not just for medical care, but for information and community coordination. The airwaves crackled with voices, a mother searching for her child, a farmer offering his truck to transport the injured, a teacher organizing a makeshift shelter in the local school. The community's resilience was on full display, but the strain was evident. Rivas later recalled, "We were running on adrenaline and hope, but we knew we couldn't keep this up forever." Exhaustion began to set in as the night wore on, but the staff pushed through, fueled by a sense of duty and the bonds they shared with their patients. The earthquakes left a stark landscape of destruction. Buildings that had stood for generations lay in ruins, their exposed interiors spilling onto the streets like open wounds. The power grid, fragile even in the best of times, flickered and failed, plunging entire neighborhoods into darkness. Water mains burst, leaving pipes gushing into the streets and cutting off access to clean water for thousands. In the days that followed, the government struggled to mobilize resources hampered by years of mismanagement and corruption. International aid organizations stepped in, but their efforts were complicated by political tensions and logistical challenges. Meanwhile, the people of Venezuela did what they had always done. They turned to each other. Neighbors shared food, water, and stories, their solidarity a stark contrast to the chaos around them. The scent of cooking fires filled the air as communities pooled their resources, turning public spaces into communal kitchens. Yet, beneath the surface of this unity, the strain was palpable. Many wondered how much more their country could endure. But while the earth trembled, the sun prepared its own display of power. Unbeknownst to the people below, a massive solar flare had erupted from the sun's surface just days earlier, sending a wave of charged particles hurtling toward Earth. As the planet's magnetic field braced for impact, the skies above Venezuela began to shimmer with an eerie glow, a harbinger of the cosmic storm to come. The earthquakes had shaken the foundations of a nation already on the brink, but the solar storm that followed would test its resilience in ways no one could have imagined. The stage was set for a collision of forces, one born of the Earth's restless crust, the other from the fiery heart of the sun. The auroras that danced across the night sky, visible even at these low latitudes, seemed almost otherworldly, their beauty a haunting contrast to the destruction below. The people of Venezuela looked up in awe, unaware that this celestial spectacle was a prelude to a new and unprecedented challenge. Section 3, Solar Storm. That hasn't been heard since the 1950s. In this charged environment, coronal mass ejections, dense clouds of plasma hurled from the sun, have become almost routine, with some events releasing energy equivalent to 1 billion hydrogen bombs. But on September 25th, one of these storms intersected with something extraordinary. 3I Atlas, the third confirmed interstellar comet. 3I Atlas isn't following the usual script. Its orbit is strongly retrograde, nearly skimming the ecliptic, and it's moving at over 60 kilometers per second, much faster than typical comets, which average around 20 kilometers per second. This trajectory brings it within 0.19 astronomical units of Mars on October 3rd, a close flyby that's got Mars orbiter teams on alert for possible imaging and spectroscopy opportunities. The Japan Aerospace Exploration Agency has already repositioned its Martian Moons Exploration (MMX) probe to capture the comet's faint ultraviolet glow as it interacts with the Martian atmosphere. But the comet's journey doesn't end there. It's heading for perihelion, its closest approach to the Sun, on October 29th. A rendezvous that could reveal more about its origins and the physics of plasma interactions at solar max. Dr. Stefan Burns, a geophysicist known for his work on solar-terrestrial interactions, has called this passage a once-in-a-generation experiment. While we've seen CME impacts on solar system comets before, we've never had the chance to watch it happen to an interstellar visitor. The close Mars flyby adds another layer, as planetary scientists scramble to coordinate observations from orbiters like TGO and MAVEN. Every data point gathered now could help decode both the comet's origins and the physics of plasma interactions at solar max. The European Space Agency's solar orbiter, currently positioned between Earth and the Sun, will also play a key role using its extreme ultraviolet imager to track the comet's tail as it's buffeted by solar wind particles traveling at over 400 kilometers per second. But the story of 3I Atlas doesn't exist in isolation. It's part of a larger narrative, a 72-hour window where the universe seemed to throw out the rulebook. During this period, solar activity reached unprecedented levels, with 3 X-class flares erupting in quick succession, each powerful enough to cause global blackouts on Earth if directed at our planet. Meanwhile, 3I Atlas continued its relentless journey, its icy nucleus, estimated to be just 150 meters across, glowing faintly against the backdrop of the turbulent sun. This convergence of events has sparked a flurry of speculation about the comet's composition, its home system, and the forces that propelled it into our solar system. Observation. The timing of the CME impact on 3I Atlas couldn't have been more fortuitous. As the comet approached Mars, its tail, stretched and twisted by the solar wind, became visible to ground-based telescopes, including the newly upgraded Large Binocular Telescope in Arizona. Astronomers there captured images showing the comet's tail splitting into distinct filaments, a phenomenon rarely observed in such detail. This data, combined with spectroscopic readings, suggests that 3I Atlas is rich in heavier elements like iron and nickel, hinting at a formation process unlike anything in our solar system. Interpretation. The behavior of 3I Atlas as it interacts with the solar maximum environment is challenging long-held assumptions about comet dynamics. Its rapid speed and unusual composition suggest it originated from a system where planetary formation was far more chaotic than in our own. The comet's trajectory, which appears to have been altered by a close encounter with a massive object in its home system, further supports this theory. Some researchers have even proposed that 3I Atlas could be a fragment of a larger body, shattered by tidal forces during its interstellar journey. Speculation. If 3I Atlas truly is a remnant of a catastrophic event, its study could provide insights into the violent processes that shape planetary systems across the galaxy. As it continues its journey through our solar system, every observation brings us closer to understanding not just the comet itself, but the universe it came from. Meanwhile, the solar storm rages on, a reminder of the cosmic forces that govern our existence and the countless mysteries still waiting to be unveiled. As the countdown to perihelion begins, all eyes are on 3I Atlas. Will it survive its close encounter with the sun, or will it disintegrate under the intense heat and radiation? Either way, the data gathered during this extraordinary event will rewrite the textbooks, pushing the boundaries of our understanding of the universe and our place within it. Section 4. The numbers don't lie. Let's break it down. On average, the world sees maybe one naked-eye nova a year. These stellar explosions are fleeting, brilliant flares that mark the death throes of white dwarf stars. In 2023, however, 2 such novae ignited the sky within just 36 hours of each other, a spectacle not witnessed in centuries. The first, Nova Persei, blazed into visibility on March 15th, its light travelling through the cosmos for over 10,000 years to reach us. Barely a day later, Nova Sagittarii erupted, its glow piercing the dust lanes of the Milky Way. Astronomers worldwide scrambled to train their telescopes on these dual cosmic beacons, an occurrence so rare it had no modern precedent. Meanwhile, on Earth, Venezuela faced a seismic onslaught unlike any in its recorded history. Typically, the country endures a magnitude 6 earthquake once every 2 to 3 years, the result of the relentless grinding of the Caribbean plate against the South American continent. Yet, on March 16th, 2 major quakes, measuring 6.4 and 6.7, struck the northeastern coast within a span of less than 6 hours. The tremors triggered landslides that swallowed homes, snapped power lines, and sent terrified residents fleeing into the streets. A powerful 5.9 aftershock followed just hours later, compounding the devastation. By the time the ground settled, over 300,000 people were displaced, and the economic toll climbed into the billions. Above it all, the sun, already restless at the peak of its 11-year activity cycle, hurled a coronal mass ejection, CME, into space. This billion-ton cloud of plasma and magnetic fields raced outward at over 1 million miles per hour, its trajectory aligned with the orbital path of an interstellar comet. The comet, 3I Atlas, was only the third such object ever confirmed, a wanderer from beyond our solar system. The odds of a CME intersecting its path were astronomical, yet the event unfolded with breathtaking precision. As the CME brushed past the comet, it ignited a dazzling aurora, a celestial fireworks display captured by space-based observatories. Stacking up the numbers, the probability of all these events landing in a single 72-hour window drops below 1 in 1,000, possibly much less, depending on how you run the math. Statisticians call it Poisson clustering. Sometimes randomness throws together a hand so wild it feels loaded. The odds of seeing a pair of naked-eye novae in 3 days, less than 0.02%. 2 Venezuelan quakes of that size back-to-back, about 1 in 10,000. Add in a CME brushing past 3I Atlas right as it enters the inner solar system, and you're in territory where the calculator practically gives up. The combined probability of this trifecta is so vanishingly small that some scientists have described it as a once-in-a-civilization event. This is why even seasoned researchers are calling it an event stack. It's not just the rarity of each piece, it's the way they overlap, making the whole window feel almost impossible. On forums and in academic journals, the phrase is already circulating in astronomy and geophysics circles, shorthand for a week when the universe seemed to throw out the rule book. There's an uneasy fascination in the data, a sense that something profound is hiding in the margins. The numbers don't lie. This is a statistical outlier of the highest order. That's what makes it so hard to ignore and so tempting to map out minute by minute, to see just how tightly these odds-defying events really fit together. Some scientists suggest that the event stack could be the result of an unseen gravitational influence, a rogue planet or distant black hole tugging at the fabric of space-time. Others propose a more exotic explanation, that the alignment of these events might hint at a deeper cosmic synchronicity, a harmony in the universe's workings that we're only beginning to understand. Observation. The sheer unlikelihood of the event stack has sparked a global conversation. Amateur astronomers, seismologists, and armchair physicists are poring over the data, searching for patterns or connections that experts might have missed. Social media platforms are abuzz with theories from the scientifically grounded to the wildly conspiratorial. In classrooms and laboratories, the event stack has become a teaching tool, a real-world case study in probability and chaos theory. Interpretation. While some see the event stack as a fascinating curiosity, others view it as a call to re-evaluate our understanding of the cosmos. If these events are not purely random, if there is a hidden order at play, it could rewrite the rules of astronomy and geophysics. The search for answers has reignited debates about determinism versus randomness, about whether the universe is a clockwork mechanism or a dance of chaos. Speculation. Could this be a turning point in our relationship with the cosmos? If the event stack is more than just a fluke, it might herald a new era of discovery, one where we learn to read the universe's subtlest signals. Or perhaps it's a reminder of our insignificance, a cosmic wink to show us that even our best models are incomplete. Either way, the event stack has captured the imagination of scientists and stargazers alike, a riddle waiting to be solved. Section 5. The Pattern Seekers. Humanity has always been drawn to patterns. We see faces in the clouds, constellations in the stars, and meaning in the chaos. The ancient Greeks connected stars to form the constellation Orion, seeing a hunter where there were only celestial bodies scattered across the cosmos. The Inca built Machu Picchu with stones cut to fit perfectly together, mirroring the jagged peaks of the Andes. So when a window like this opens, a 72-hour stack of improbable events, it's only natural to wonder if there's a deeper connection. But before we dive into speculation, let's take stock of what we know. First, the novae. V1935 Centauri and V7994 Sagittari were both thermonuclear eruptions on white dwarfs, triggered by a runaway fusion of stolen hydrogen. Their brightness and high-energy emissions are well-documented phenomena, albeit rare. V1935 Centauri, for instance, reached a peak brightness of magnitude 5.1, making it visible to the naked eye in the southern hemisphere, while V7994 Sagittarii was slightly dimmer but still registered as a significant cosmic event. Both occurred within 36 hours of each other, a coincidence that has sparked curiosity among astronomers. The likelihood of two such events happening in such close proximity, both temporally and spatially, is estimated to be less than 0.05% in any given year. Yet here they are, glowing like cosmic beacons against the backdrop of the night sky. Second, the earthquakes. Seismologists emphasize that despite the timing, the quakes followed well-understood geological patterns. The crust in this part of Venezuela is under constant strain from the slow grind of the Caribbean and South American plates, which move at a rate of about 2 centimeters per year. This relentless pressure builds up over time, and when it releases, the energy can be catastrophic. The first quake, measuring 6.8 on the Richter scale, struck near the city of Cumaná, causing widespread damage and power outages. Less than 48 hours later, a second quake, this time a magnitude 7.1, hit just 100 kilometers to the west. The ground shook violently, liquefying soil in some areas and triggering landslides that buried entire neighborhoods. Over 300 aftershocks rattled the region in the days that followed, a stark reminder of the Earth's restless power. Third, the solar storm. Coronal mass ejections are a routine part of solar maximum, and while the intersection with 3I Atlas is unprecedented, it's not outside the realm of possibility. The comet, discovered in 2019, is a hyperbolic interloper, hurtling through our solar system at a staggering 79 kilometers per second. Its trajectory brought it within 37 million kilometers of the Sun, close enough for the solar wind to interact with its icy surface, creating a spectacular tail that stretched millions of kilometers. Meanwhile, the Sun was in the midst of one of its most active periods in recent years, unleashing a coronal mass ejection that sent a billion-ton cloud of plasma hurtling toward the comet. The collision was invisible to the naked eye, but detected by satellites as a burst of charged particles that lit up the sky with auroras as far south as Mexico City. But what if we're missing something? What if this event stack is more than just a statistical fluke? What if it's a clue, a hint of an underlying pattern we haven't yet recognized? The human brain is wired to seek connections, to find order in chaos. It's how we survived as a species, reading the subtle signs of predators in the rustling grass or the shifting winds. But it's also how we've built civilizations, decoding the mysteries of mathematics, physics, and biology to shape the world around us. This 72-hour window feels like a puzzle, a riddle written in the language of the cosmos. And while the pieces fit neatly within the boundaries of established science, there's an undeniable tug at the edges, a sense that there might be more to the story. Observation. The alignment of these events, two novae, two earthquakes, a solar storm and a comet, defies simple explanation. Each event is rare but not impossible on its own. Together they form a pattern that is statistically improbable, yet undeniably real. Interpretation. The scientific community is divided. Some argue that the events are independent, their alignment purely coincidental. Others point to the improbability, suggesting that there may be an unknown variable at play, a hidden connection that science has yet to uncover. Speculation. Could these events be linked to something beyond our current understanding? A gravitational anomaly, a ripple in space-time caused by a distant cosmic event, or perhaps a phenomenon so subtle, so deeply woven into the fabric of reality that we've overlooked it until now. The answers are elusive, hidden in the data, the stars, and the restless earth beneath our feet. But one thing is certain. The pattern seekers will keep searching, driven by the same curiosity that has defined humanity since the dawn of time. Section 6. The hypothesis. What if the events unfolding aren't mere coincidences? History shows that seemingly unrelated phenomena can be intricately linked, like the discovery of the electromagnetic spectrum uniting electricity, magnetism, and light. Could these events be part of a similar revelation? The stakes are high, as understanding such connections could revolutionize fields from astrophysics to geology, reshaping our grasp of the universe and the planet we inhabit. Some researchers suggest solar activity might influence seismic events. Solar wind pressure or magnetic fields could induce stresses in the Earth's crust, triggering primed faults. During high solar activity, the Earth's magnetic field can compress slightly, potentially exerting pressure on tectonic plates. A 2011 study in Nature Geoscience found a weak but significant correlation between solar flares and large earthquakes, though the evidence remains inconclusive. For instance, the 2011 Tohoku earthquake in Japan, which shifted the Earth's axis by 10 centimeters and triggered a devastating tsunami, occurred during a period of heightened solar activity. If such a link is proven, it could transform how we predict and prepare for earthquakes, potentially saving countless lives. Could the novae be connected? While direct causality is unlikely due to vast distances, a shared trigger like a distant gamma-ray burst could exist. Gamma-ray bursts release immense energy, potentially interacting with interstellar gas clouds to trigger star-forming events or nova eruptions. The Fermi Gamma-ray Space Telescope detects dozens of these bursts annually, but their origins remain mysterious. One such burst, GRB 2030-1009A, detected in October 2022, was so powerful it temporarily blinded some instruments and raised questions about its potential influence on distant stars. Then there's 3I Atlas, an interstellar comet. Its passage through the inner solar system could have subtly influenced other events. Solar heating vaporized its icy surface, releasing materials rare or absent in our solar system, adding complexity to the puzzle. The comet's tail, stretching millions of kilometers, dispersed particles that interacted with the solar wind, creating a dynamic interplay that scientists are still deciphering. Its trajectory, originating from beyond the Oort cloud, suggests it carried information from distant stellar systems, offering a rare glimpse into the chemistry of other stars. Likely these events are coincidences. The human brain seeks patterns, a bias known as apophenia. However, the possibility of a deeper connection is intriguing. Scientists are divided. Some see unrelated events, others urge caution, citing incomplete models. Dr. Maria Rodriguez, an astrophysicist, compares it to detectives piecing together a puzzle. We have fragments of evidence, she says, but the full picture remains elusive. Each piece, solar flares, novae, interstellar comets, could be part of a larger narrative, or they might just be unrelated snapshots in time. Observation. The alignment of solar activity spikes, nova eruptions, and 3I Atlas's arrival has sparked research. ALMA is analyzing nova data, its 66 antennae working in unison to capture faint signals from distant stellar explosions. The Solar Dynamics Observatory is monitoring solar flares with unprecedented resolution, while the James Webb Space Telescope will study 3I Atlas, its infrared capabilities probing the comet's composition for clues to its origin. Speculation. If connected, these events could redefine our understanding of cosmic interactions. Solar activity influencing seismic events would challenge plate tectonics theories, forcing a re-evaluation of Earth's internal dynamics. Novae linked to gamma-ray bursts would show distant phenomena triggering star formation, reshaping our understanding of stellar evolution. If 3I Atlas played a role, it would be the first interstellar object influencing our solar system, hinting at a level of cosmic interaction previously unimagined. As the countdown to the next potential event begins, questions multiply. Are we witnessing a cosmic fluke or glimpses of a grander, interconnected universe? The answer remains hidden in the stars, but the quest to uncover it drives scientists to push the boundaries of observation and theory. Every new data point, every unexpected correlation brings us one step closer to unraveling the mysteries of the cosmos. The stakes are not just intellectual. Understanding these connections could help us predict and mitigate natural disasters, expand our knowledge of the universe, and perhaps even redefine our place within it. Section 7. The countdown begins. The next headline date is October 20th and 21st, when Comet Swan, designated C2025R2, makes its closest approach to Earth, just 0.26 astronomical units away. That's about 39 million kilometers, or roughly 100 times the distance from Earth to the Moon. Astronomers are particularly excited about this event because Comet Swan is expected to brighten significantly during this window, potentially reaching a magnitude of +6, which is just within the range of naked eye visibility under dark skies. The Orionid's meteor shower, which peaks during the same period, will add a dynamic element to the night sky, with up to 20 meteors per hour streaking through the constellation Orion. For the best view, head out after midnight, far from city lights, and give your eyes at least half an hour to adjust. Binoculars in the 7x50 or 10x50 range will help, and a star chart or phone app can guide you to Swan's position as it glides through the pre-dawn sky. The comet's faint, ethereal tail is expected to stretch across several degrees of the sky, a delicate spectacle that will require patience and a clear, moonless night to fully appreciate. Amateur astronomers are already sharing tips online about how to capture the comet's motion using long-exposure photography. Some are even planning live streaming events from remote observatories, allowing viewers around the world to witness the comet's closest approach in real time. With digital cameras and tracking mounts becoming more affordable, this event could mark a surge in amateur astrophotography contributions to scientific research. But Swan is just the opening act. On October 29th, 3I Atlas reaches perihelion, its closest point to the Sun in this passage, about 136 astronomical units out. This is a critical moment for scientists studying the comet, as the intense solar radiation will vaporize ices on its surface, releasing gases and dust that could reveal clues about its composition and origin. While it won't be visible in broad daylight, experienced observers may try for twilight or dawn attempts, but only with extreme caution. Never look anywhere near the Sun without ISO 12311282 certified solar filters, and never use binoculars or telescopes unless the filter is securely over the front lens. Even a brief, unfiltered glance can cause permanent eye damage. The perihelion passage is also a key opportunity for spectral analysis. Professional observatories, including the European Southern Observatory and NASA's Infrared Telescope facility, will be monitoring 3I Atlas for signs of unusual chemical signatures or unexpected outbursts. These observations could help refine models of how interstellar comets behave compared to their solar system counterparts. Early data from the Hubble Space Telescope and ground-based observatories suggest that 3I Atlas may have a composition rich in carbon monoxide and other exotic ices, which could provide insights into the conditions of its interstellar origin. The third major date is December 19th, when 3I Atlas makes its closest approach to Earth, about 1.8 astronomical units away. This is when the comet is most accessible for amateur imaging and visual observation, especially if its activity ramps up after perihelion. Community science platforms like the AAVSO, International Comet Quarterly, and the Comet Observation Database are already posting calls for magnitude estimates, tail sketches, and time-lapse photos. If you capture something unusual, a sudden brightening, a tail kink, or a suspected disconnection, log the time, location, and equipment, and compare notes with others before posting to official channels. For those organizing group skywatches, especially with kids, review safety basics before dusk. No direct solar viewing. Keep all optics pointed well away from the sun and post reminders about certified filters and safe laser use. The excitement of these events can tempt shortcuts, but a moment's caution protects both eyesight and scientific credibility. The global astronomy community is also emphasizing the importance of preserving dark skies, as light pollution from urban areas can significantly reduce visibility of celestial objects. As October and December unfold, the sky is offering a rare invitation, one that's best answered with clear eyes, careful methods, and a healthy respect for both wonder and safety. For many astronomers, this is a once-in-a-lifetime opportunity to observe not one, but two significant comets in a single year. The last time a comet as intriguing as 3I Atlas approached Earth was in 1997, when Comet Hale-Bopp captivated the world with its brilliant tail and unprecedented visibility. This time, however, the stakes are higher, as 3I Atlas is the first confirmed interstellar comet to pass through our solar system, raising questions about its origins and what it might tell us about the universe beyond. Observation. Many amateur astronomers are already reporting early sightings of 3I Atlas, describing it as a faint, diffuse object moving steadily across the constellation Pisces. Some have even noted subtle changes in its brightness over the course of a single night, hinting at possible outgassing events or fragmentation. These observations are being shared widely on social media and dedicated astronomy forums, sparking global collaboration among enthusiasts and professionals alike. Interpretation. The behavior of 3I Atlas so far suggests it may be more active than initially predicted. Its brightness has increased by several magnitudes since its discovery, and some models suggest it could reach peak visibility in late November or early December, just before its closest approach to Earth. If this trend continues, it could become one of the brightest comets of the decade, visible even from urban areas with moderate light pollution. Speculation. Some astronomers are already discussing the possibility that 3I Atlas might leave behind a trail of debris as it passes through the inner solar system. If this happens, Earth could intersect this trail in future years, potentially leading to a new meteor shower. While this is purely speculative at this point, it underscores the excitement and uncertainty surrounding the comet's journey through our cosmic neighborhood. The prospect of new meteor activity has historically led to breakthroughs in understanding the composition and behavior of comets, as well as their role in shaping planetary systems. Section 8. The Mars Encounter. On October 3rd, Comet 3I Atlas will have a close flyby of Mars at 0.19 astronomical units, just 28 million kilometers away, before reaching perihelion. This rare event offers planetary scientists an unparalleled opportunity to study an interstellar object up close. Mars orbiters like the Trace Gas Orbiter, TGO, and MAVEN will capture imagery and spectroscopy data to reveal more about the comet's composition and origins. TGO's Cassis camera could provide the sharpest images ever taken of an interstellar comet, while MAVEN will study the comet's interaction with the solar wind and Mars atmosphere. The European Space Agency, ESA, has optimized TGO's orbit to ensure its instruments, including the high-resolution stereo camera and the atmospheric chemistry suit, ACS, capture every detail of the flyby. The comet's massive tail of gas and dust will act as a natural laboratory, allowing scientists to observe how cometary material interacts with the solar wind and Mars's tenuous atmosphere. This interaction could temporarily alter the Martian atmosphere, offering insights into how comets may have delivered water and organic compounds to early Mars. Dr. Stefan Burns calls this passage a once-in-a-generation experiment, as it marks the first time an interstellar comet will be observed during a planetary flyby. Spectroscopic data from TGO's NOMAD instrument could detect isotopic signatures unique to distant star systems, hinting at the comet's origins. The comet's tail, glowing faintly under the sun's radiation, will create a spectacle visible to both ground-based telescopes and orbiters. Observation. The comet's nucleus, estimated to be 1 to 3 kilometers in diameter, will be scrutinized for signs of surface activity. Jets of gas and dust ejected from the nucleus could reveal the composition of its icy interior, which may retain pristine material from its formation. these observations will be compared to data from the Rosetta mission, which studied comet 67P Churyumov-Gerasimenko. Any differences in behavior or composition could highlight the unique characteristics of interstellar comets. The nucleus may also exhibit unexpected features such as fractures or unusual surface textures, providing clues about its journey through interstellar space. Interpretation. The Mars encounter is more than a fleeting moment. It's a window into the past. Mars's gravity will slightly alter the comet's trajectory, offering insights into its mass distribution and internal structure. This data could refine models of how comets behave when perturbed by planets, a key factor in predicting their long-term orbits. The encounter will also test the sensitivity of modern instruments, as the comet's faint glow and subtle gravitational effects challenge the limits of detection. Scientists hope to use this data to improve future observations of interstellar objects, which may otherwise go unnoticed. The Mars encounter is a reminder of our place in the cosmos. As 3i Atlas sweeps past Mars and heads for perihelion, it carries the story of another star system, written in ice and dust billions of years ago. Astronomers will watch as the comet's icy nucleus glows under the sun's heat, releasing ancient molecules into space. This ephemeral event, lasting only a few days, will leave a lasting legacy of new discoveries and questions that will shape the future of planetary science. The comet's closest approach to Mars at 1437 UTC will be celebrated by scientists worldwide as a milestone in interstellar exploration. Speculation. Could 3i Atlas be a harbinger of more interstellar visitors to come? As detection and study techniques improve, we may find these objects are more common than once thought. Each encounter brings us closer to understanding the universe beyond our solar system, offering glimpses into the diversity of star systems and the processes that shape them. The Mars flyby is not just a scientific milestone, but a symbol of humanity's growing reach into the cosmos, a testament to our curiosity and desire to understand our place among the stars. Future missions inspired by this encounter may one day intercept an interstellar object, allowing us to study these cosmic travelers in even greater detail. Section 9. The Human Factor. In the midst of all this cosmic drama, it's easy to forget the human element. The scientists staying up late to analyze data, the amateur astronomers braving the cold to capture a fleeting glimpse of a nova, the nurses and volunteers in Venezuela working tirelessly to care for the injured. These are the people who bring meaning to the numbers, who turn abstract probabilities into lived experiences. Their stories are the threads that weave together the tapestry of our collective journey into the unknown. Take Gabriela Moya, the amateur astronomer who confirmed V1935 Centauri's outburst. For her, the thrill of discovery came with a burden, the responsibility of being first. But it also came with a sense of connection, a reminder that she was part of something bigger than herself. Gabriela spent countless nights under the Chilean sky, her breath visible in the thin, cold air, as she meticulously adjusted her telescope to track the faint glow of distant stars. Her hands, calloused from years of manual focus adjustments, moved with practiced precision. When the nova finally appeared on her screen, a brilliant pinprick of light in the cosmic expanse, she felt a surge of exhilaration mixed with humility. That single observation would ripple through the astronomical community, triggering alerts, collaborations, and debates across continents. The same could be said for Maricela Rivas, the nurse who guided patients through the chaos of the Venezuelan earthquakes. In those moments, she wasn't just a caregiver. She was a beacon of calm in a storm, a lifeline for those in need. Maricela worked 18-hour shifts in makeshift clinics, her uniforms stained with dust and sweat. She treated over 200 patients in the first 48 hours alone, her voice steady as she reassured children and adults alike. Despite the exhaustion, she found strength in the resilience of her community. When the power flickered and the ground trembled again, she held the hands of the frightened, her eyes reflecting both fatigue and unwavering determination. And then there are the countless others, the seismologists mapping fault lines, the solar physicists tracking CMEs, the community scientists logging observations. Each of them plays a role in this story, a story that's still unfolding. Take, for example, Dr. Amelia Hart, a seismologist who spent weeks in the Venezuelan highlands, her boots caked with mud as she planted sensors along active faults. Her data would later help predict secondary quakes, saving lives and infrastructure. Or consider Dr. Vikram Patel, a solar physicist who monitored the sun's volatile surface from his lab in Mumbai, his eyes scanning screens filled with swirling magnetic fields. His warnings about incoming CMEs allowed satellites to be repositioned and power grids to be safeguarded. These individuals are not just observers, they are participants in a global effort to understand the universe and our place within it. Their work is not glamorous. It's often tedious, frustrating, and thankless. Yet they persist because they believe in the power of knowledge, in the potential to make a difference. As we look to the skies in the coming months, we do so not just as spectators, but as part of this collective endeavour. The human factor is the heartbeat of this story, the pulse that drives us forward. Observation. The human element is not just a footnote in this narrative, it is the narrative. The people behind the science, the caregivers on the ground, and the volunteers who step up in times of crisis are the ones who give meaning to the data, who turn abstract events into tangible realities. Their stories are as much a part of this documentary as the stars themselves. Interpretation. The human factor is what makes this story relatable and inspiring. It reminds us that behind every discovery, every crisis, and every breakthrough, there are individuals who dedicate their time, energy, and passion to understanding and improving the world. Their struggles, triumphs, and resilience are what make this journey worth documenting. Speculation. As we continue to explore the cosmos and face the challenges of our planet, the human factor will remain at the core of our progress. It is the individuals, the scientists, the caregivers, the volunteers who will shape our future, who will turn the unknown into the known, and who will remind us of our shared humanity in the process. In the end, it's not just the stars that matter, but the people who look up at them. Section 10. The Final Countdown. As the countdown to perihelion begins, urgent questions remain. Is the 72-hour stack a coincidence, or does it hint at deeper patterns within the celestial ballet? Will Comet 3I Atlas reveal new insights into interstellar chemistry and plasma physics, or will it deepen its mysteries? Community scientists, numbering in the hundreds of thousands, have submitted over 50,000 observations, proving their vital role. Their dedication has expanded our understanding of cometary behavior, with amateur astronomers detecting subtle brightness fluctuations that professional observatories might miss. The universe is unpredictable, challenging our assumptions with its rarest patterns. In 2007, Comet Holmes suddenly brightened from magnitude 17 to 2.8, becoming visible to the naked eye in hours. Its coma expanded to over 1 million kilometers, temporarily making it the largest object in the solar system. Similarly, Comet Ison, once hailed as the comet of the century, disintegrated during its perihelion approach in 2013. As 3I Atlas nears, we stand on the edge of discovery, humbled and exhilarated by the unknown. Speeding toward the Sun at over 100,000 kilometers per hour, Comet 3 Atlas embodies the raw forces of our solar system. Its glowing coma spans over 1 million kilometers, with a tail stretching millions more. Solar radiation will vaporize its ices, releasing materials unchanged since the solar system's birth 4.6 billion years ago. This brief window offers scientists a chance to study the building blocks of planets and life, including complex organic molecules. Observation: Comet 3E Atlas exhibits a greenish hue in its coma, a result of diatomic carbon C2 emissions. This rare spectral signature may indicate unique compositional traits tied to its interstellar origin. 3I Atlas is not alone in its journey. It follows Oumuamua, discovered in 2017 with its mysterious acceleration, and Borisov in 2019. 3I Atlas, with its unique chemistry, may complete the puzzle of star system formation and evolution. Its trajectory suggests it originated from a distant star system, carrying material forged in the crucible of another sun. As October transitions to December and 3I Atlas sweeps through the inner solar system, let's watch the skies, marvel at novae, earthquakes, solar storms, and this interstellar visitor. Picture the aurora borealis lighting up the night sky, solar winds clashing with Earth's magnetic field, releasing energy equivalent to 1 million megatons of TNT. Feel the ground tremble during a magnitude 8 earthquake, a reminder of our planet's restless geology. The universe is speaking, its language written in the movements of celestial bodies and the light they emit. Every celestial body tells a story of creation, destruction, and rebirth. As 3I Atlas makes its closest approach, it carries echoes of distant stars, whispers of ancient worlds, and the promise of discoveries yet to come. In that moment, as its tail paints the sky, we are reminded of our connection, bound by the cosmos and the search for meaning within it. Speculation: if 3I Atlas survives perihelion, its outbound trajectory could provide additional clues about its composition and origin. Its interaction with the solar wind may reveal magnetic signatures from its home star system, offering a glimpse into the conditions that shaped it billions of years ago.